So here we get into disaster. You ready? You ready for
Yes.
disaster? Okay,
Yes.
so what do you know about global warming, Philip? What about the things that cause global warming or that are forcing factors in global warming?
Well, I guess I would say greenhouse gases. That's what I hear about. CO2.
Right?
That's pretty much my understanding. And there may be other gases that, go in the atmosphere and trap
Water.
heat
Water
and
is
water.
one. Yeah.
Oh, yeah. Oh,
Greenhouse gases. So we have, yeah, water actually, water vapor is a massive, massive forcing factor
oh.
in and a greenhouse gas.
So
People
we
don't
should get
think
rid
of
of
it.
water? Yeah, it's
Yeah,
clearly a problem.
totally. Yeah, no.
That is literally throwing the baby out with the bathwater.
Yeah.
Yeah.
But, as everything heats up, more water vapor ends up in the atmosphere. The water
Mhm.
vapor is part of the magnifying factors, or what
Mhm.
we call a forcing factor. Um, so people are like, water, it's not bad. No, it's not. Carbon dioxide, we know, has a very long lifetime. Carbon dioxide, methane, ethane,
Mhm.
all those organics that are up there, ozone. Oh
Mhm.
my
Mhm.
gosh,
Mhm.
that one, that's the cancer in Australia. Um, um, but now microplastics.
Oh, in the air? Or
Yes, yes.
oh my god.
Just published in Nature Climate Change. Dun, dun, dun. Microplastic and nanoplastic particles are pervasive in the atmosphere.
Wow.
Nobody understood what impact they had. There's all sorts of things. There's dust in the atmosphere, there's pollution in the atmosphere, there's everything. Bacteria, fungal spores, everything. Everything ends up in the air and
Mm.
people are just like, "It just smells so clean." No, no. It's really
Mm.
it
This
depends.
Dasani bottle
Uh,
just smells
yeah,
so good.
they're so
Um,
good. Yeah.
wow. So is I
So
know they're in the water. Well, like, they're in the ocean, right? These
yes,
microplastics,
but when we
somehow it gets
talk
into the air.
about micro and microplastics, like, that's actually big size particles, right? Like, this is
Huh.
stuff you can see. Nanoplastics are the littler, tiny, tiny things that are
Mhm.
much harder to see and to strain out. Um, and recently there was a report, and it is talked about in this field all the time about, um, how they ensure that they're not, like, dirtying their samples because there is a lot of work that people are reporting on. "Plastic's bad, microplastics are bad, it's in your bones, it's in your brain, it's in your testicles, it's everywhere, polar bears to wherever," and there is some truth to that. There's a lot of truth to that, but at the same time, it's unclear as to how accurate all of those measures are. And still to this day, we are unsure as to the impact on biology.
Hmm.
Aside from when little animals eat plastic, it gets in their digestive system, it doesn't get digested, and then they die.
Mhm.
So there's the one thing that everybody talks about, which is like, "Oh, the reproductive system and plastics have estrogens, and so is this going to impact the reproductive system and blah, 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 or plastics are very sticky, and so
Hmm.
pharmaceuticals and other pollutants are going to stick to the plastics, and then they're gonna impact the frogs." These are iffies. These are very iffy questions that nobody has, like, really clearly answered at this point in time.
Hmm.
But brand new yes, brand new answer. Dun, dun, dun. Airborne microplastics trap nearly 1/5 as much heat as black carbon. Black carbon is one of the worst pollutants, in our atmosphere for trapping heat. That's a physical,
Hmm.
body. Black carbon is soot. It is, left by burning, volcanoes.
Huh.
Um, yeah, it's not great, but there's a lot of, this microplastic that ends up aerosolized, apparently some of it through breakdown products. So, like in the West Pacific Gyre, Gimbling
Mm.
Gyre, I think it's Gyre. Um, but in the Pacific Gyre, where plastics seem to be collecting along with a whole bunch of other garbage, aerosols are coming from there as well. So it's part of now a new feedback loop
Wow.
of particles and how particles end up in the atmosphere.
Wow. Wow. And I could say, uh, everybody saw the pictures that came back from Artemis. Went to the
Mm,
moon, and these
are
magnificent
we
pictures of Earth. And among the many kind of stunning images are those ones where you can see the atmosphere is just this ridiculously thin, layer of little bit of glowing, in the
Yeah,
sunlight around the Earth. And so,
yeah,
yeah. So now it's full. That is, you can imagine that full of all these other things that shouldn't be there and that are trapping the heat. They're basically right. An interesting thing about these greenhouse gases or things, pollutants, is that it seems like they let the sunlight in, right? So the sunlight comes from the earth and it gets through
mhm,
them, somehow hits the ground,
yeah,
heats up the ground. Then the
yep,
heat comes off the ground, but the heat is trapped, right?
yes.
And just builds
As
up and builds
Blair
up.
likes to say, it's an insulating blanket.
Ah, yeah, yeah, yeah.
Where you can imagine there's like a small amount of heat that might leave, right? But
Mhm.
it traps all that wonderful heat inside. And
Mm,
so this is another ingredient that we had not added to all of our models.
mm,
So this is actually very interesting because understanding what is in the atmosphere. So we have this understanding of, okay, the atmosphere is heating, the lower atmosphere, the upper atmosphere heating at particular rates.
mm,
What's in it that is contributing to the speed of the heating? And over time, we're like, okay, black carbon, um, greenhouse gases, water vapor, let's add these things to the list of what works. And we're getting better ideas of how each of them work and what they do.
mm,
This breaks down that like unknown component that has been, like C in E equals MC squared. It's,
yeah,
it's just fudge factor, right?
yeah, yeah.
It makes that it's not as much of a fudge factor anymore. It gives more
Mhm, mhm,
accuracy because now we can say this component, and I will tell you what they found here, is that the global surface concentrations reach 4.18. Wait, what are the mega I don't know what the P stand microplastics? Oh, yeah, 4.18 microplastics per meter cubed for micro I don't know what MP stands for. This is something that I should have figured out, and I apologize that I don't know the exact nomenclature for this. 3.67 nanograms per meters cubed for nanoplastics, and, this means that there is 4 microplastic and nanoplastic particles, 0.039 plus or minus 0.019 watts per meter squared, equivalent to 16.2% of black carbon forcing. And this means that they found peaks over the North Pacific subtropical gyre, gimbal and Wabe, exceeded local black carbon by 4.7 fold. So they were unrecognized and um, very impactful.
mm, yeah.
So
And another possible reason why, I mean, don't they say that the Earth seems to be heating up more than
faster than
estimated?
expected. And
Yeah.
so maybe having something that was unrecognized before be recognized, we can start to put timing to it and say, oh, this is how it plays in the equation,
Mhm,
right?
mhm.
Yeah. So yeah, that's what I was thinking too. You just said it. Maybe this is part of the explanation of why it's going faster than we thought.